And welcome to today's lesson on circles. We're going to be talking about topics in the standard 2.6 in geometry and that study island topic called circles. This is part 2 of 2 videos about circles in geometry, so you want to make sure that you watch both of them. Today's video, we're going to be talking about secant and tangent lines in a circle. So a secant line is a line that crosses a circle twice, and a tangent line is a line that crosses a circle once. And as always, just remember our study tips. You can pause, rewind, fast forward as much as you need to. So if you are taking notes, which I highly recommend, you can, and I go too fast, just pause and catch up. And then you can also pause at the beginning of a question, work it out, see how you did, and then come back and watch what I did, and that way you can check yourself. So I'm so glad that you're here, and let's go ahead and take some notes. So the first rule that we're going to be looking at today is an angle that is created by 2 secant lines has a measure that is equal to half the difference between the corresponding arc measurements. So that's what this says in words. This is what it looks like as a picture in the formula. So what you're going to be doing is you take your 2 arc measures, subtract them, divide it in half or multiply it by half, and that's going to give you this angle right here. And so there's a lot of these just little rules about circles, and they're just kind of things that you have to study and get in your head before you take the EOI, before you take your tests and your curriculum. And because once you know them, these questions are pretty easy. I mean, you're mainly just subtracting and splitting a number in half to get answers. All right, so here I have 2 secants, a line that crosses through the circle twice, and it wants to know what is the measure of angle QNR, so that's this little angle here. If you know that the arc measure is PO is 34 degrees, and the arc measure of QR is 94 degrees. And they go ahead and give us the formula over here that we need to use. And so we're basically going to have 1/2 times, and then the measure of QR is 94 minus the measure of PO is 34. And that's going to give us the angle we're looking for. So when I go ahead and do that subtraction, because you do parentheses first, that gives me 60. And then half of 60 is 30. So my answer here is 30 degrees in letter B. And I would highly recommend when you're doing these problems to copy the picture down and label them like I did here, so you're not trying to keep everything in your mind. This question is very similar, only there's going to be a different piece missing than what we're used to. So it says if the arc EF is 43 degrees, so I'm going to go ahead and label that, and the measure of angle BCD is 30 degrees, what is the measure of arc BD? So it wants to know what is this measure here. So that means I'm going to have to, instead of just using this as a formula, I'm going to have to use it to set up an equation to solve. So I know that the measure of angle BCD is 30 degrees, and that equals 1/2 times the quantity, and then that arc measure BD, that's what I'm looking for. So I'm going to put an X there. And then that subtraction of arc EF, I know that a measure the arc EF is 43 degrees. So I'm going to write 43. So now I just solve. So the first thing I'm going to do is get rid of parentheses, and I'm going to do that by distributing this 1/2. So 1/2 times X is 1/2 X. And then 1/2 times 43 is 21.5. And that's still equal to 30. So now it's a 2-step equation. So I'm going to add 21.5 to both sides. And here these 21.5s cancel. And on the left, I'm left with 51.5 equals 1/2 X. And then I'm going to divide both sides by a half. And these halves cancel. And you could use 0.5 in your calculator here if you want to, or if you have fraction button, you could use 1/2. And then 51.5 divided by 1/2 is 103. And that equals x. And x is what I'm looking for here, so my answer is D, 103 degrees. Our next rules are going to deal with secants or secants and tangent. So remember, a tangent of a circle has two defining properties. The first is it touches the circle at exactly one spot. Not secant touches it twice, a tangent touches the circle once. And where that tangent intersects the circle's radius forms a 90-degree angle. So a tangent and a radius or a tangent and a diameter are perpendicular because they form a 90-degree angle. Okay, the first theorem or rule we're going to look at is if you have two tangent segments to a circle from the same external point, then they're congruent. This picture here says to think of it as a hat. I've also thought of it as an ice cream cone, because the diagram looks like a circle wearing a pointed hat. Or if you flip it, it kind of looks like an ice cream cone. And you want, whether it's a hat or an ice cream cone, you want those sides to be even, because if that's ice cream and one of these sides is shorter, your ice cream's going to fall on the ground. And that's going to be a very sad time. Or if you're thinking about it as a hat, you don't want your hat to be sitting lopsided. You want those to be even sides. So end of story. If you have two tangents starting at the same place, from that intersection to the circle, and those two lines will be congruent. The next rule deals with having a secant and a tangent. So if you have a secant and a tangent that start from the same external point, then the product of the length of the secant segment and its external segment is equal to the square length of the tangent segment. So what that means is if you take this length of the tangent from A to B and you square it, that's going to be equal to, if you take the length of BC, the outside part, times the entire secant length, B to D. So now let's look at some problems that use these two rules that we just talked about. So in the figure above, the line TQ is tangent to the circle with a center of S at point Q. And the chord RQ is a diameter of the circle. So if you know that X is 20 degrees, what is the measure of PQT? Someone wants to know, what is this right here? Well, remember when we talked about the definition of a tangent, we said that a tangent line and a diameter form a 90-degree angle. So that means this here is a 90-degree angle. So I know X takes up 20 of that right angle. So if I take 90 minus 20, I'm left with 70 for angle PQT, which is what I'm looking for. And so my answer is A. This example here says triangle DEF is circumscribed about circle R. Points S, T, and U are points of tangency, where length SD is 5 and length UF is 7. What is the measure of D to F? So it wants to know, what is this whole measure here? Well, this is our hat or ice cream cone rule. So if I know that U to F is 7, then F to T is also 7. And then if I know that C to D is 5, then D to T is also 5. So if I want to know the whole way from D to F, I'm just going to take 5 plus 7, which is 12 meters. And that's our answer, C. This is a similar problem. We have triangle DEF is circumscribed about circle R. points S, T, and U are points of tangency, where you know that length ES is 6 centimeters, and you know that length TF is 17 centimeters. And it wants to know, what is the measure of E to F? Well, same thing here. It's the party hat or ice cream cone rule. You know that E to S is 6, and U to E also has to be 6. And if you know that T to F is 17, then you know U to F also is going to be 17. So if you want to know this whole length, you're just going to take 6 plus 17, which is 23 centimeters, and that makes my answer C. All right, this last example deals with having a secant line and a tangent line, and they're nice enough to give us this rule written out for us. So it says if the length of HJ is 5 inches and the length of JK is 120 inches, what is the length of HI? And then it tells us that HI is indeed a tangent line, so we're not assuming. Okay, so I have my formula here, and it says HI squared, which is the tangent part, and that's what I'm looking for. So I'm going to have x squared equals, and then it says the length of H to J, which is 5. So that's going to be 5, and then times the length H to K. So H to K is 5 plus the 120, so it's going to be 125. So I have x squared equals 5 times 125, which is 625. And then I have x squared. To undo that squared, I'm going to take the square root of both sides. The square symbol and the square root symbol cancel because they're opposite operations, and I'm left with x equals the square root of 625 is 25. So my answer is C, 25 inches. I'm glad you joined us today, and I hope you learned something new.